Chapter 18, and we're going to look at the next theorem. So the first theorem we did was, where am I after putting this? Oh yeah, sorry. So the first theorem we did was the vertically opposite angles. Second theorem was alternate angles, and now we're moving on to the third. Okay, and the third one is, you can see it here highlighted, is about corresponding angles. Corresponding angles, they have a lot of similarities with alternate angles, so they're not the same, but I'll explain what I mean now in a second. So corresponding angles are on the same side of a transversal that cuts two lines. One angle is in between the lines and the other angle is outside the lines, okay? So when you're doing these, the similarities with alternate angles comes from the fact that to look for corresponding angles, you need parallel lines. Okay, so there's my parallel lines. Just put my symbol on. Yeah. And you also need a transversal. Okay, so exactly the same as for alternate. You need, these are the requirements to even look for a corresponding angle. So that's the similarities, okay? Now, when we're doing a alternate angle, if I'm not going to do it, but can you see the highlighter over here? You look for the Z, so you go along the parallel line, down the transversal, along the parallel line, and you find your Z shape. For corresponding, we look for an F shape. Okay, so you go down the transversal, one arm on the on the parallel line, one arm on the corresponding. Why do I keep saying that? So you go down the transversal, one arm on the parallel line, the other arm on the parallel line. Okay, and the corresponding angles are on the same side of the transversal. One angle is in between the lines and the other is outside. So what we're talking about is this angle and this angle. So they're on the same side of the transversal. One is in between the lines, one is outside the lines. They are corresponding. Yeah? So let's try another one, because remember, it's just the F shape. It doesn't have to be an actual F. So I'm going to remove these. Sorry, I'm trying to remove the pink without removing the... Not bad, lost the transversal, can fix that. So throw my transversal back in. Right, so if we look at, you could do an upside down F, right? So say there's along the transversal, and then parallel line, and then one in between the lines, and one outside of the lines. They are corresponding. So it goes through it down here. Okay, so there's your here is your regular F shape. That's the one I've just drawn there, the upside down one. And then you can go backwards. So there's a backwards F here, and then an upside down backwards F here. Yeah? Okay, and every time the corresponding angles, see them? They're on the same side of the transversal. So these two are on the right. Remember, this is the transversal. So they're on the right of the transversal. One is in between the lines, one is outside. Here's my transversal, so they're both on the right as well. The H is in between the lines, the G is outside. Okay, and then same over here. Here's my transversal, so both of these are on the same side. They're both on the left. The A is in between the lines, the B outside. Is that okay? So that's how you pick out corresponding angles. And the theorem says that if we have two parallel lines, then corresponding angles formed by a transversal are equal. Okay, or slightly more normal. Corresponding angles are equal in measure. Okay, so in order to get a corresponding angle or corresponding angles, you need your parallel lines and your transversal. You find them. the corresponding angles, that is, by making the F shape. And if all of those things have fallen into place, then what you have, those things you found, are equal. Okay? And now there's just a little hint here. You can figure it out using other ways, but it's handy. Can you see here the interior angles between the two parallel lines? Do you know what I mean? So A is in between the lines and B is in between the lines. They add up to 180. That's not a theorem because you can figure it out using other theorems. It's just a little helpful hint. Okay, so just throw that into your notes. Okay, so we'll have a look at this one. And now I'm going to do it. You can do this again. You can do this a couple of ways. I'm going to force myself to do this using corresponding angles just because that's what I'm trying to teach you. Okay, so parallel lines, transversal. Yeah, that means I can look for my corresponding angles. It meets the kind of criteria. Corresponding angles I will find using an F shape. So I go down the transversal, one arm on a parallel line, one arm on a parallel line. So there's my F shape. Now that's going to tell me, I should probably I'll do it properly. So that F I've drawn tells me that this angle on the outside and this angle in between are equal. Okay, so that's not really helping me because it's this angle here, see that one there, that I'm trying to figure out. So what I should have drawn was an upside down F. So let's do that. Okay, so down the transversal, one arm on the parallel line, one arm on the parallel line. So there's my F, yeah, upside down. So the two angles are in between the lines, outside the lines. So they're equal. Yeah? So I can say that that angle there is 50 degrees. Is that fair enough? Lines. Yeah. Okay, so you can see that they're the same. Is that okay? Then if we look, this is a straight line, which means these two angles sitting on it must add up to 180. So angle A plus 50 degrees equals 180 degrees. So if I do 180 minus 50, I get 130 degrees. So angle A is equal to 130 degrees. Now, my reasons for that. So I found this because of corresponding angles. So I found that F shape. And then the reason I knew this bit was because they formed a straight angle. Okay? Right, so that's theorem 3. That's your corresponding angle theorem. Now, I'm going to contradict what I said in the homework video. I know I said I do 1 or 2 theorems, but I was just looking, and the next, I was going to do 2 because that's obviously done now, it's quite quick. But the next one kind of links in with 2 others. So I'm going to do the 3, they're triangle theorems. I'm going to do the 3 of them on Monday. Like, they're fine, and they link so heavily together that it's really hard to do a question. Like, if I were to teach you 1 today, I wouldn't be able to give you a question because it links with the other ones. Yeah? So I'm going to do 1 today and those 3 on Monday, and that's actually that chapter finished. So I will be moving on to the next chapter just to do 2 theorems out of it. Okay? Now, I'm not finished here. I am going to just introduce triangles to you. This is stuff you probably already know. Okay? So there are 3 types of triangles where they kind of fit a structure. And these will need to be kind of taken down into your copies. So the first one is equilateral. An equilateral triangle is where all sides are the same length and all angles are the same size. Okay, and they all happen to be 60 degrees. Now, just a couple of little symbols we use in geometry. So see these little lines? See these? they are a symbol to say that they are all the same length. So if I were to draw a triangle and I were to go 1, 2, 1, 2, I am telling you that these sides are the same, but this one is different. Looks like a face. Does that make sense? Okay, so they're little symbols. Those little lines mean something. They're telling you that they are the same size or length. Okay, so if you have a triangle where all three sides are the same and all three angles are the same, there's a name for that. It's called an equilateral triangle. Okay, the second type of triangle that you need to know is an isosceles, and that's where you have two sides are being the same length and two angles are the same size. Okay, so you can see, hopefully, the little lines here. So they're telling you that those two sides are the same. And again, these angles, so they have a little angle symbol and inside they have a dot, an angle and a dot. And they're telling you that they are the same size. Okay, so the sides are the same and the angles are the same. Okay, and just because we're going to need this the next day, it's always this side, the angles opposite the sides that are equal. So if I go from this side and point at that angle, and this side and point at that angle, that's always the structure. So if I were to do an isosceles triangle over here, for example, right, and I said that this side and this side were the same length, and I asked you to pick out which angles were the same, you would start here and draw an arrow over, and then you would start here and draw an arrow over. And it is these angles that are the same. Okay, so the angles in an isosceles triangle that are the same are always opposite the sides that are the same. Okay, but what's important here is an isosceles triangle has two equal sides and two equal angles. And then the last one is a scalene triangle, and a scalene triangle has no equal sides and no equal angles. Okay, so you can see no symbols whatsoever, no lines, no dots, nothing is the same in a scalene triangle. Is that all right? So just take down your notes on those triangles. Equilateral, same sides, same angles. Isosceles, two of the same sides, two of the same angles. And scalene, none the same sides or angles. Okay, so if you take down your notes on those, and the three theorems we're going to do on Monday are all going to be based on triangles. Okay, so I'll give you homework just based on, now I can't really do it based on corresponding alone. It's kind of corresponding, again, I've just added another tool, okay? It's everything now. So you have your straight angles, your full angles, your vertically opposite, your alternate, and now your corresponding. So the homework I've given you is kind of based on all five. Is that okay? So have a go with that. That's due for Monday. And like I said, we'll do the three terms on Monday.